Good evening, millennials. Today we'll be looking at the 104th problem, maximum depth of binary tree in the LeetCode website. So it's an easy problem, so let's look at the shortest way to write code for this solution, for this problem. So let's look at the problem. Given the root of a binary tree, return its maximum depth. So what is maximum depth? A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. Okay, so let's look at the example to understand it. So here we are given a binary tree and we are asked to find the maximum depth. So the maximum depth of this is 3, 20, 15 or 327, which is 3. We don't need to print the path, but we just need to return the depth. So the root is given as an array of the tree using a reference structure, tree node and int.val, and we have the left pointer and right pointer, and we have the constructors, 3 constructors, and yeah, that won't be required here because we are not creating any new tree node. Let's look at another example. When there's only 1 and 2, there are 2 nodes, so the depth will be 2. So the number of nodes in the tree is in the range 0 to 10 power 4. Okay, so it's in 0 to 10 power 4 and the nodes values are between minus 100 to 100. So since we are asked to find the maximum depth, we have to traverse through the tree once using various traversal methods. It can be in order, level order, or anything. Let us note that, let's write the base condition. During the base condition, when the root is null, after the leaf node, the depth will be 0. Else we can directly return the depth as 1 plus the depth of the maximum of the left and right subtree. So here if you see, the maximum depth up till this point will be maximum depth of its 1 plus maximum depth of its left and right subtrees and plus 1, and when we come here the maximum depth will be 1 because for the leaf nodes the maximum depth will be 1. So let's write the solution. So this seems like a simple problem, so I think I can write it in a one-liner. So return if root equal to null, which means there's no root, I just return 0. Else I am just using a ternary operator, else I return 1 plus the same. I again call this in recursion max depth of, so I need to find the maximum of the left and right max depth, so it should be the max depth of root arrow left and the compared with the max depth of root arrow right. So for each thing I have to add 1 and 1 plus that max depth of root arrow left and root arrow right. So I think this should give the solution. Let's just run the code to make sure we haven't made any errors. Yeah, it's accepted for this case. I just ran it a few times to prevent any errors, and yeah, as you can see it beats 89.47 of the C++ solution, and this seems like the shortest solution and the cleanest code to write in an interview. If you can think of a more cleaner approach or faster approach, please leave it down in the comments below. We are always open to constructive feedback. Thank you.